Number one, I have two functions here. I have the f of x and the g of x. Okay, I want to find g of x, which is x squared minus 2, minus, make sure you put this in parentheses, the f of x, which is 4x minus 3. All I have to do is simplify. Okay, x squared minus 2 minus 4x plus 3. I end up with x squared minus 4x plus 1. Number 2, find the f of g of 3. The first thing I have to do, find the innermost parenthesis g of 3. G of 3, I just put in 3 for x. So I get 3 squared minus 2, which equals 9 minus 2, which equals 7. So I'm going to replace the g of 3 with 7. So I have to find the f of 7. Just plug in 7 for the x. I get 28 minus 3, which is 25. Ask him if he has to return his cap and gown. Cap and gown. How? I believe that. All right, transformations. Transformations, anything in any kind of mathematical symbol, whether it's parentheses, square root, absolute value bars. Inside the mathematical symbols, you go left or right. It's opposite the sign. Outside the symbols, it's up or down, follow the sign. So what are we going here? Left or right? That's correct. Left 6 and down 3. Seniors, you are lucky we didn't get to number 4, so you don't have to do 4. Number 5 is a growth problem. So you're using y equals a times quantity 1 plus or minus r raised to the t. Now, our a is going to be our initial amount. Let's see, our r is the rate. Okay, so let's figure this out. At a town with a large convention center, the cost of a hotel room has increased 4.1%. So that's our rate. Rate must always be a decimal, not percentage. So we're going to move the decimal point over 2. That gives me 0.041. The average hotel room cost, so this is my initial amount. That's my A. And in 1980, and this growth continues. Create a function that models the exponential growth of the room price starting in 1980. So I have y equals my A, my initial amount is $39, times 1, this is growth, so we're going to use plus, times my rate, which is 0.041, raised to the t. Okay, the second part of this, it says, what will the room cost in 2020? So what's my t? From 1980 to 2020, what's T? That's right, 40. Okay, so Y equals 39 times 1.041 raised to the 40. Put that in your calculators and vape it. What do you get? That's right, $194.58. So this question actually has those parts. Hey, seniors, you get another big break. You don't get to do 6. Juniors will do this on the multiple choice test because we have 2 weeks to do more trig. Okay, number 7 is also a growth decay problem. In this case, what is it? That's right, it's decay because my B is 1/3. Now, if you didn't know that, what are you going to do with this? You didn't know anything. You're looking at this problem and says, I don't know what the hell to do. Don't skip it. Yeah, make an educated guess, but use your calculators, right? Plug it in there and see what happens. Okay, so yeah, anything with domain and range and end behavior, graph it. Right? So I've got 1/3 raised to the x minus 4. Graph it. Okay. Now, what's my domain here? What are my x values of this graph? That's right, negative infinity, positive infinity. For growth and decay, yes. Range. Okay, it's good, but to get that exact asymptote there, go to your chart, okay? It's not getting close to -3, it's getting close to -4. Never quite reaches it, so parenthesis. Yes, sir. No, exactly like this. Multiple choice is going to be for juniors on test day, on final day. Okay, these always stay the same, negative infinity, positive infinity. Okay. There's 3 finals. Part 1, part 2, and then multiple choice. Seniors are only taking part 1, part 2. They're taking part 1, part 2, and multiple choice. Yes, everybody's doing the fun. Okay, as x goes to the left, what's happening to my y? It's going to positive infinity, right? X goes to the right. Where's my y going? Trying to get to that -4, right? Number 8, we really didn't go through, but it's not that hard to figure out. But after I did it with my other 2 classes, we're not going to do it. Actually, we could. No, we can't. No, I'm not going to count. All right, number 9. It's not that hard to figure out, but for some reason, I guess it is with you guys. How many zeros do I have in x cubed plus 7x squared plus 4x minus 12? 3. I have 3 zeros. Do you know what they are? Well, we could easily find out by put it in our calculators. So I have x cubed plus 7x squared plus 4x minus 12. Graph it. My zeros look to be -6, -2, and 1. Let's double check. Let's go to our chart. And look at that. -6, -2, and 1. Okay, number 10. Okay, how do I factor when I have 4 terms? 4-term factoring. 4 terms. 4 terms. 4 terms. Factoring 4 terms. How do I factor 4 terms? Any ideas? Anyone? Anyone? There you go. Break it up into 2 groups. It's called factor by grouping. Okay, what can I take out of the first group? Well, you're the only one that got that. X to the second. 2x plus 3. How about the second group? What can I take out? A 4. I get 2x plus. Good. Hey, look at that. Yeah, be careful. Make sure this doesn't factor anymore. Sums of squares do not factor further, but differences will. I'm sorry, I didn't understand you. As a matter of fact, in number 11, Jenna factored 3x squared minus 48x. She took out the 3x, got the x squared minus 16, but she did not go farther. Why? 16 is 4 squared, right? So you can actually factor that x plus 4, x minus 4. Now, this is where the more funner stuff started to begin. Yes. No, it says if not, what was the complete factor? Way too many. I think I'm down to like 115, 118. All right, number 12. Let's factor everything, right? So kids just don't care. There are, yeah. Now this is going to be the first semester. Our stuff, rationals. Let's rewrite these. 7x over x plus 8. Please put these in parentheses. Times 4x minus 5. You're right, they did take more time out of class. Divide, I'm going to change to multiplication and flip it. So I have my x plus 8 up on top. I can factor this, right? Different squares. This is 4 squared, x squared, 5 squared. So this is going to be 4x minus 5, 4x plus 5. Okay, let's cancel out. X plus 8, 4x minus 5. That's it. 7x over 4x plus 5. Okay, 13. I have addition, so what am I going to need? Least common denominator. Multiply the denominators. X minus 5. X plus 1 happens to be my least. So I have x minus 5, x plus 1. Okay, what am I going to multiply the first fraction by? X plus 1, right? Plus 3. What am I going to multiply the 3 by? Yep. Now I just simplify the top. X times x, x squared, x times 1 is 1x. Positive 3 times x is positive 3x. Positive 3 times negative 5 is negative 15. Combine like terms. So I get x squared plus 4x minus 15 all over x minus 5, x plus 1. Please make sure that you can't factor this and cancel out, which I don't think we can. So we're good. All right, number 14, what's the least common denominator? Multiply the denominators. X times x plus 6. Nothing's repeating. We're good to go. Number 15. This is a log base 3. If you can't read it, that's a 3. What undoes logs? Exponents. So we're going to exponentiate this so that 3 base 3 cancels out. So I get x minus 8. And what's 3 to the 4th? 3 times 3 times 3 times 3? 81. Add 8 to both sides. $16. Got it, Donald? 16. Here I'm doing the opposite. I have exponents, so I need to find the logs. Now remember, I told you guys, if you have different bases here, try to make them the same base. Can I make 625 into a power using base 5? Divide 625 by 5. What do you get? Get 125, right? Okay, divide 125 by 5. Divide by 5. So 4 times. 5 times 5 times 5 times. Okay, I changed 625 to 5 to the 4th. Now I can take log base 5 on both sides. And what does the log base 5 do to the 5? Cancels it out. So I get 2x minus 3 equals 4. Add 3 to both sides and divide by 2. And 17. What are the excluded values? What do the excluded values do? Make the denominator 0. Okay, so the first thing you want to do, factor all denominators. Such language. Such terrible, terrible language. Okay, what's going to make my denominator 0? 7's one of them. So x cannot equal 7 or negative 7, right? This is our note key day 1. What is this, 4th hour? Monday, May 13th.